And let's assume we want to conduct a survey where we can actually see the population of the student data set is around 10,000. And this is the total number of students who are studying, let's say, in a university. And you know that approaching to all 10,000 students uh, is difficult. So what we can do is we can take a sample out of these 10,000 students. And for that purpose, we conduct a survey. And in this survey, we want to see uh, two important parameters of the regression line, the y-intercept and the beta coefficient. In this video, we are focusing upon the beta coefficient. Now, you know that the beta coefficient will be representing the rate of change in GPA due to the study hour. And after taking the survey, we find out the beta coefficient is 1.25. And what we want to do is we want to see that is this beta coefficient is actually representing to the whole population. Now, this question is really important. Again, note that this value of 1.25 is coming from the 100 students, which is our sample. So sample could be any value. You can take 50, 100, 200, but it should be less than 10,000. And the adequate of the sample size depends upon your total number of population elements. So in here, we simply taking 100 students. And just reflect your thoughts on the previous concept that we have discussed about the regression line, and the more effective regression line would be that actually represents to the all points. In hypothesis testing, we want to make sure that the regression line is actually reflecting or representing to the all population elements. Now the question is that is this value is significant? Significant mean that can we say that the 1.25 is actually representing to the whole population, which is 10,000 students. And you know that uh, the null hypothesis, which can be that the beta coefficient is zero. And again, this is a vague idea where we are actually start our hypothesis. This is called the null hypothesis. Here you can see that we are taking the null hypothesis beta is equal to zero. And you know that this claims could not be justified. There must be some beta coefficient value, which is the alternative hypothesis. And obviously, we want to, in our mind, we want to prove the alternative hypothesis. And the ideal situation would be where the null hypothesis will be rejected and we accept the alternative hypothesis, which is representing with H1. So how do we know that the beta coefficient value is significant? For that purpose, you can say that we have criteria, and intuitively speaking, we are having a judge, which is called the P. The P value is actually determine whether the beta coefficient value is significant or not. So ideally, it should be the P value should be less than 0.05%. So in this scenario, when we are 95% sure and giving 5% margin of error, so we are safe in between 1.10 beta coefficient and 1.40 beta coefficient. So these are the upper and lower values, which are acceptable. Let's assume that we have a p-value which is 0.002. After calculating, again, the software will give this value automatically, will calculate automatically, and you just have to see that is this value is less than 0.05 because this is the judge, and we can see that this is less than 0.05. So the beta coefficient, which is 1.25, is statistically significant. So this is the technical terminology that we normally use, that this beta coefficient is actually representing to the whole population, which is 10,000 students.